Okay, class, so I'm going to go over the solution to the problem that I gave you yesterday. Okay, so part I asks to find the area of the shaded region. Okay, so the area is just integrating the curve. So it's going to be 1/2 x to the 4 minus 1. Now the only difference is that this is actually underneath the x-axis. You're used to the ones on top. Works the same way, you just do your limits of integration. So instead of doing from here to here, we're doing from here to here. Okay. So instead of starting at 0 and going up to something, we're starting at -1 and going up to 0. Or -1/2, sorry, and going up to 0. Okay. So we're still integrating area bound by the curve between these two limits. Okay. So basically the 1/2 can come out front because it's a constant. X to the 4 minus 1 dx. So basically we just need to take the derivative of each of these, the integration of each of these separately. So raise that by 1 gives us 5, divide by that. And then that's x to the 0, so raise that exponent by 1, which is x to the 1. Okay, so we get that. And we're our limits of integration are from -1/2 to 0. Oh, actually, wait, sorry. We should be doing 0 to 1. Okay. Yep. 0 to 1. Sorry about that. Because we're doing x values. I was thinking about one of the next sections. Okay. So plug in 1. That's pretty easy. Plug in 0. All that goes to 0. That's pretty easy. So you get 1/2. That's 1/5 minus 1, which is -2/5. Okay, so that's I. Alright, double I. Double I asks us to find the volume when this is rotated about the x-axis. So that's pi. Since we're doing it about the x-axis, so that's y squared dx. Okay, now our limits for doing x, so still 0 to 1. Okay, so pi 0 to 1. We got to square this. So 1/2 squared is 1/4 squared dx. Okay, so full this out. Just 1/4 I can bring out front because it's a constant again. And full this out. Pull that out, you get x to 8. If you know how to integrate that, if you remember how to integrate that, which you should, you could just do it straight from there, or you can fold it out. So you get that if you fold it out. Okay, plug in, let's do our integration. So that's x to the 9th over 9. 2 to the 5th, x to the 5th, minus x. That's integrated from 1 to 0. Plug in 1. 1/9 minus 2/5 minus 1. Plug in 0, it all goes to 0. And subtract that, let's see, we get 8 pi over 45. Okay? So that's the volume when obtained by rotating it around the x-axis. Triple I is rotating it now about the y-axis. So if we're going about the y-axis, that's x squared dy. Means we need to solve this equation for x squared. So let's do that first. Okay, multiply by 2. Add the 1 over. Now to get rid of this 4, I do the 4th root. Okay? Or you can write it like this, if you want to do it with exponents. 1/4. Remember, 1/2 means square root, 1/4 means fourth root. Now, I have to square it. So when I square this, I'm doing that. So remember, when you have power to a power, you just multiply. So that just makes this whole thing to the 1/2. So my equation, or I'm sorry, my integration is 2y plus 1 to the 1/2. Okay, and my limits of integration, because we're going y now, so it's going to be negative 1/2 to 0. Okay. So integrate that. So we can't fold this out like we did up here because it's to a 1/2. So you have to use that integration for the chain rule. Okay, so remember, you raise this by 1. So add 1 to that. So 1/2 plus 1 is 3/2. Okay, you divide by that. Okay, just like normal, you divide by whatever you raised it by. Then we multiply it by the derivative, well, whatever a was. Remember, ax plus b is whatever a is. So 2. Okay, and this whole thing is evaluated from negative 1/2 to 0. Plug in 0, it obviously all goes to 0. Plug in 1/2. 1/2 is only here, so half of, negative 1/2, so half of 2 is negative 1. That goes to 0. Okay. Oops. Sorry. And so we get v is equal to, so the only thing that's going to be left then is pi over 3. Okay. So hopefully you'll be able to follow through. That was quite a bit of work on that one. If you need to, message me on Teams. Pretty sure I worked out every step, but if you need me to explain something more in depth, just message me on Teams. Okay, thanks guys.